Alright, hopefully we should be able to get through this in this video. Going down to the last problem. This is the lab problem. Free response 5 is always a lab problem. It says we got 3 beakers, beaker 1, beaker 2, and beaker 3, and they all contain one solution. Our job is to figure out which it contains. So it says when a drop of beaker 1 is added to a drop of beaker 2, a precipitate forms. Based on this reasoning, what is the identity of beaker 1? Okay, so we know that in beaker 1, since they're all with nitrates, we don't have to worry about the nitrates. We got Ag plus, we got Na plus, and we got Li plus. I don't worry about the nitrates because nitrates are always soluble. Okay, not going to have to worry about that at all because it's never going to be the thing that causes the precipitation. And in beaker 2, they're all chlorides. Okay, so when Ag is with Cl, we get a precipitate. When Na is with Cl, we get no precipitate, and when Li is with Cl, we get no precipitate. So beaker 1 must be AgNO3. Okay, they want you to explain. Okay, AgNO3 because Ag plus and Cl minus is insoluble and no other combinations are insoluble. Thus, AgNO3 must be the presence, the compound in beaker 1. Beaker 2 is a pink solution. Okay, so we know that it must contain a transition metal. Okay, based on this information, what is the identity of beaker 2? All right, so there are 2 solutions with transition metals, COCl2 and CuCl2. So COCl2 is a pink solution, and CuCl2 equals a blue solution. And you can go back to lab 1.3 to look at this. So COCl2 must be the identity of beaker 2. Write and balance the reaction between beaker. This should be 1 and this should be beaker 2. Okay, so beaker 1 is a solution of AgNO3 and beaker 2 is a solution of CO2 plus Cl minus. They are in water, remember, because we have these molarity signs everywhere. So I'm rewriting them in their ion form. I see ions, I see no neutral atoms, so I'm going to swap. I do not see near the OH and the NH4 or the H plus and CO3 2 minus. So this is going to be a swap stick with a precipitate. We know that nitrates are always soluble, so that can't make the precipitate. So the precipitate is going to be AgCl. So Ag plus Cl minus goes to AgCl. My spectators are the CO2 plus and the NO3 minus. This should be a 3 here. Okay. When a drop of beaker 2 is added to beaker 3, so we know that beaker 2 is CO2 plus Cl minus, and when it's added to beaker 3, a precipitate forms. What 2 solutions could you narrow down beaker 3 to? Okay, let's do it with the first one, and sodium carbonate. So Na2 plus, Na plus, CO3 2 minus. So that swaps. This can't be the precipitate, but CO and CO3 can be the precipitates. So it could be Na2CO3. That's one option. Okay, CO2 plus Cl minus plus Na plus OH minus. That's going to be this next one. Swap. We know that alkali metals can't be the precipitates. OH does work with CO2 plus as well. So we know that NaOH can be. So now we have 2. We can narrow it down to Na2CO3 or NaOH. Okay? And we can narrow it down to those 2 because CO3 and that's this combination, and COOH2, that's this combination, are both insoluble. Okay, last one. When a drop of dilute hydrochloric acid is added to beaker 3, a gas is liberated. So we know that when you add H plus to something containing CO3 2 minus, it produces CO2 and H2O. This is from our stick box. So we know that the identity of beaker 3 must contain CO3 2 minus. So Na2CO3 must be beaker 3 because CO3 2 minus reacts with H plus to produce or liberate a gas. Love you guys. Oh, hold on. So let's go through and circle this. So that is the answer. So beaker 1 is AgNO3, beaker 2 is COCl2, and beaker 3 is Na2CO3. Peace.